Let's look at this pattern in code. I've prepared an example here that we can use and refactor with the observer pattern. I'll explain this one by going through the various components. The first thing we need to look at is the thermometer. And the thermometer has a temperature that it keeps track of, a temperature in Kelvin. It has a few constants that shows me how to format it when I'm printing it out. And we have just a little bit of implementation. One is a callback method that comes from the driver. So this is a new driver value. And just to make it simple, I just took the driver value and divided it by 100. We said that is the temperature in Kelvin. And then we have a few accessor methods that give me the temperature in various formats or in various units of measure, Kelvin, Celsius, and Fahrenheit. Next, let's look at the driver implementation. It's not that important what we're doing here, but it's basically a simulator that produces events and calls the thermometer's driver value at regular intervals. And I have a few configuration parameters that allows me to play around with how often I create an update and also the range in which an update can occur, how many degrees up and down it can go if you want. I made the driver a subclass of a thread. That means it has its own thread running. There is a run method. But really the critical piece is that at some regular intervals, it will call a thermometer and say, here's the new driver value, and pass in some value that fluctuates up and down. I also created a setup class. This is basically just a convenience class that sets up the experiment. In the constructor of setup, I create the thermometer. I then create the driver and pass in that thermometer, and then I start up the driver. There is also a method for clients or those that have access to the setup to get to the thermometer itself. And finally, I have a simple shutdown method that allows me to close down the experiment. Finally, I created a simple client to test this out, and I call it the polling thermometer client. Nothing special here either. There is a constant that I've created that allows me to say how long I want to run in seconds. There is a constant for saying how long between the pulls that I want to achieve. So that would be 50 milliseconds here. I usually run with 100, but right here I run with 50. I create a setup. That's the one that creates the thermometer. So I need to grab that thermometer from them. But it's useful here to see the symmetry. So the setup has a corresponding shutdown. I grab the thermometer. And then I basically just calculate times through the loop I have to run for that 20 seconds in this case. And then there is basically just a loop. And all it does is it sleeps for X number of milliseconds. And then it goes and asks the thermometer what the temperature is. In this particular example, every 50 milliseconds. And that's kind of the completion of this test client. Now let's run the polling thermometer client and see what happens. The system will now start to print out the whole set of messages. I'll freeze the frame here so we can see it. And we see, for instance, in this example, that we only had 4 driver updates, but we've been checking the temperature 101 times. We're printing out a ton of checks. In fact, there's about 400 of them. And the driver has actually only updated 11 times. This is obviously a complete waste of resources. Let's illustrate what's happening with a simple drawing. We have 3 objects in play here, the driver, the thermometer, and the client. Obviously, we also had the setup, but it's not really important for now. The driver has its own thread that I'll draw in red here that sends out the driver value message to the thermometer. The way we have it set up, it will do so about every 5 seconds on average. The client is using the main thread, and I'll draw that in blue, and the client uses this thread to go and ask the thermometer for the new temperature. Because the client doesn't know when the driver has updated thermometer, it basically is forced to do a whole set of polling, and it does so actually in our example every 5 milliseconds or so. Apart from being annoying, it's obviously a waste of resource, but it also has latency that is unnecessary. Depending on how frequently we poll, half of that interval between 2 polls is our latency. So if we poll every 100 milliseconds, we would have a latency of, say, 50 milliseconds. So not only do we waste resources, but also we have a latency that is suboptimal. So let's try to fix this by applying the observer pattern. The first thing I'll do is I'll add an interface that I'm going to call the observer. The observer will have a simple method called update, and I'll give it parameters later. Next, I'll create an abstract class that I'm going to call observable. The observable will have to hold the registration behavior. This is where observers will register themselves for updates. I'm going to make a set of observers. Probably could implement this as a list. I'm going to make it a set, so I make sure that observers are not added twice, so they go multiple updates. In some cases, you may want this to be a list if you want to guarantee that dependent objects or the observers are called in a particular order. But I don't really want that behavior. Next, I'm just going to add a couple of accessor methods that allow you to add observers and remove observers, or register yourself as a dependent and remove yourself as a dependent. I will also add a constructor to make sure that the collection of observers have been created prior to use. And finally, I'll create a protected method, meaning a method that can only be called from the subclasses, that I'm going to call notify dependents. All that is doing is it iterates through all the observers and tell them to update. Now, I told you I would come back to the update method's parameters. And what I want to pass on as a parameter is basically the observable object. So I'll fix that in the interface and also then pass on myself when I call the observers. Now that we implemented the observer and the observable, we can go back to the thermometer and make sure that that extends observable. That is going to be the observable object. We also have to make sure that when the driver tells us that there is a new temperature, that we notify all our dependents. And we do that by simply calling super.notifyDependents. So what will happen now is anytime that the driver gives us a new value, we will set the value and then we will broadcast that change to anyone that is listening. And that behavior of broadcasting is happening on our base class observable. Now let's create a client that works with the observer pattern. I'm going to start by copying the polling thermometer client so we can see the refactoring. I call the client observer thermometer client, and I have to make sure that it implements the observer interface. We then have to implement the update method. I'll simply copy the print statement from the previous main into the update method. The print method depends on a thermometer called T. We know that the observable coming in is a thermometer, so we can simply cast it to a thermometer. There is no reason for us to keep track of times we call it anymore, so I'll remove that. I'll create a constructor, and perhaps I should pass in the setup to the thermometer client. I'm not sure I absolutely need that, but we'll see. I'll add it for now. I don't need these constants anymore. I can delete those. I'll create a new observer thermometer client in main and pass in the setup. And we can remove most of this algorithm. Probably all we need is to sleep for, say, 20 seconds until we shut down the experiments. And right now I can't see why we need to pass this setup to the thermometer client. So I think I'm going to refactor that and remove the need for setup. I have a warning here that I haven't used the variable client. Probably need to use it later, but for now let me just suppress the warning. Now let's see if it works. Let's try to run it. When we run it, we see on the console that we do get the driver updates, but we never get the temperature printed out. And this is because we forgot to register the observer client with the thermometer. Someone needs to add the client as a listener to the thermometer. I can do it here in main. We could, of course, have done it inside the client also. Now that we're using the client variable inside main, we should be able to remove that suppress warning. We'll run it again, and we now see that we're getting one printout for every driver update. with no latency. As soon as the driver has an update, the thermometer calls its dependence, the thermometer client prints it out.